Imagine an AI that doesn't just respond to your text, but can look at a messy room and suggest where to start cleaning, or listen to a conversation and understand the underlying emotions. This isn't science fiction anymore. Major tech labs have just unveiled groundbreaking multimodal AI models that are literally giving artificial intelligence the ability to see and hear, transforming our understanding of what AI is truly capable of. The future of human-AI interaction is changing right now. What's up, tech fans? Kelly here, and today we're exploring the mind-bending world of multimodal AI, the cutting-edge technology giving AI its very own senses. The landscape of artificial intelligence is experiencing another seismic shift, perhaps its most profound yet. For years, AI excelled in specialized domains, brilliant at processing language, or mastering complex games, or even generating stunning images from text prompts. But these were largely siloed intelligences, each operating within its own data modality. Now, just this week, we're seeing major breakthroughs unveiled from leading research institutions, pushing the boundaries into what's known as multimodal AI. This isn't just an incremental update, it's a foundational leap. Multimodal AI means artificial intelligence is no longer confined to understanding just text or just images. It's learning to combine different sensory inputs, seeing, hearing, and reading, to build a more comprehensive and human-like understanding of the world. Think about how humans perceive reality. We don't just read words, we interpret facial expressions, listen to tones of voice, observe body language, and understand the visual context of our surroundings. Our intelligence is inherently multimodal. Until recently, AI largely lacked this integrated perception. But with the latest advancements, AI models are starting to synthesize information from various sources simultaneously, leading to incredibly sophisticated reasoning and interaction capabilities. This shift is not merely about adding more features. It's about moving AI closer to a form of general intelligence, capable of perceiving and reasoning about the complex, messy, and interconnected world we inhabit. It opens up an entirely new chapter in how we interact with and how AI understands our reality. This represents a pivotal moment, transforming what we thought was possible for artificial intelligence. The implications are vast, touching every aspect of our digital and physical lives, from how we work and learn to how we communicate and create. We are witnessing the birth of AI that can truly engage with the world, not just abstract data. This week's announcements highlight that this future is not just coming, it is already here and accelerating at an unprecedented pace. The ability for AI to connect concepts across different domains, like linking a visual scene to a spoken command, is what makes these new models so incredibly powerful and transformative. It's truly a game changer. So, how does multimodal AI achieve this incredible feat of integrated perception? At its core, it's about training AI models on vast datasets that contain different types of information linked together. Imagine billions of images paired with descriptive text, or videos with spoken dialogue and transcriptions, or even sensory data from robots interacting with their environment. Traditional AI models might process an image to identify objects, or process text to understand sentiment. Multimodal models, however, are designed with architectures that allow them to learn the relationships between these different data types. For instance, a model might be shown an image of a cat playing with a ball and simultaneously be given a text description. A playful cat chasing a red ball. Over time, through sophisticated neural networks, the AI learns to associate the visual concept of a cat with the word cat, and the visual action of chasing with its linguistic equivalent. This cross-modal learning allows the AI to develop a richer, more nuanced internal representation of the world. It's not just recognizing pixels, it's understanding the meaning behind those pixels in relation to other forms of data. The challenge lies in creating unified representations that can bridge the gap between inherently different data structures, like the raw pixels of an image and the sequential tokens of language. Researchers employ techniques like shared embedding spaces, where information from different modalities is transformed into a common format, allowing the AI to compare and understand them in a consistent way. This allows the AI to perform complex reasoning tasks that require integrating information from multiple sources, like answering questions about an image, generating descriptions for videos, or even creating new content that combines text, visuals, and audio. It's a complex dance of algorithms and data, orchestrated to mimic the human brain's ability to seamlessly integrate sensory information. The latest models are exhibiting an almost uncanny ability to link disparate pieces of information, leading to truly intelligent responses that weren't possible just a few years ago. This ability to synthesize information from multiple streams is what makes these models so revolutionary, paving the way for AI systems that are truly aware of their environment. The real game changer with multimodal AI is its capacity to move beyond mere text processing. While large language models have stunned us with their linguistic prowess, they've been largely blind and deaf to the physical world. Now, imagine an AI assistant that, when you show it a photo of your garden, can identify specific plants, suggest gardening tips, and even predict optimal watering schedules based on local weather data it pulls from the internet. This is no longer theoretical. Recent demonstrations from leading tech companies have shown AI models performing exactly these kinds of tasks. They can analyze images and videos with unprecedented accuracy, not just identifying objects, but understanding spatial relationships, actions, and even abstract concepts within a visual scene. Similarly, audio comprehension has reached new heights. These advanced models can not only transcribe speech, but also recognize different speakers, identify emotions in their voice, and even understand environmental sounds, distinguishing between a dog barking and a car horn, for example. When these visual and audio inputs are combined with natural language processing, the AI gains a truly holistic understanding. It can watch a cooking video, understand the steps, listen to the narrator's instructions, and then generate a recipe, complete with visual cues from the video. This level of comprehension means AI can interact with the world in a way that feels far more natural and intuitive to humans. It's about more than just recognizing patterns. It's about interpreting context across different sensory channels. This breakthrough significantly expands the potential applications of AI, moving it from specialized tasks to more general-purpose problem-solving in dynamic, real-world environments. The ability to process and synthesize information from sights and sounds, just like a human, is what truly sets these new multimodal models apart and defines the next generation of artificial intelligence, promising a future where our digital companions are far more aware of our physical surroundings. These advancements in multimodal AI are not just confined to research labs. They are rapidly finding their way into real-world applications, granting AI new superpowers that are already impacting various sectors. In healthcare, for instance, multimodal AI can analyze medical images like X-rays or MRIs, combine them with patient history from text records, and even listen to a doctor's consultation notes to provide more accurate diagnoses and personalized treatment plans. The ability to cross-reference visual data with textual insights offers a level of diagnostic precision previously unimaginable. For education, imagine an AI tutor that can not only explain complex concepts, but also analyze a student's facial expressions and tone of voice to gauge their understanding or frustration, adapting its teaching methods in real time. This dynamic, empathetic approach to learning could revolutionize personalized education. In robotics, multimodal AI is crucial for creating machines that can truly understand and navigate complex environments. A robot cleaning a home can see obstacles, hear commands, and understand the context of its surroundings to perform tasks more efficiently and safely. And for everyday consumers, the next generation of virtual assistants will be dramatically more intelligent. No longer just a voice interface, these assistants will be able to see what you're seeing through your phone camera, understand your environment, and provide contextually aware assistance, whether you're assembling furniture or trying to identify a plant in your garden. This integration of sensory perception allows for more intuitive and powerful interactions, making AI a more seamless and helpful part of our daily lives. These cutting-edge applications are just the beginning, demonstrating how AI's newfound ability to see and hear is unlocking unprecedented levels of functionality across countless domains, making our lives easier, safer, and more productive in ways we are only just beginning to comprehend. The practical impact is undeniable and growing by the day. As multimodal AI continues to evolve, the future of human-AI interaction promises a seamless symbiosis, blurring the lines between our perception and that of artificial intelligence. Imagine a world where your smart glasses don't just display information, but an embedded AI sees what you see, hearing what you hear, and offers real-time insights or assistance tailored to your immediate environment. Walking through a foreign city, it could identify landmarks, translate street signs, and even guide you through a conversation with a local, all while understanding the nuances of the situation visually and audibly. In professional settings, consider architects or designers collaborating with an AI that can interpret their sketches, listen to their verbal descriptions, and instantly generate 3D models or suggest design improvements, understanding both the creative intent and the technical requirements. This isn't just about faster processing. It's about a deeper, more intuitive partnership. The AI will anticipate needs, proactively offer solutions, and engage in conversations that feel genuinely intelligent and contextually aware. We're moving towards a future where AI isn't just a tool, but a highly perceptive companion that understands our world in a profoundly integrated way, enabling new forms of creativity, problem solving, and communication. This next era of AI interaction will be defined by its ability to fluidly navigate the complexities of human experience, providing support that feels less like using a machine and more like collaborating with an incredibly knowledgeable and aware entity. The potential for enhancing human capabilities and enriching our daily lives through this seamless integration is immense, promising a future where AI augments our senses and understanding in unprecedented ways, making every interaction richer and more informed. While the advancements in multimodal AI are incredibly exciting, they also bring forth a crucial set of ethical considerations and challenges that we must navigate carefully as we journey further into this new frontier. The ability of AI to see and hear raises significant questions about privacy. If AI systems are constantly perceiving and interpreting our environments, how do we ensure our personal spaces and conversations remain protected? Data security becomes paramount, and robust regulatory frameworks will be essential to govern the collection and use of such sensitive multimodal data. Furthermore, the potential for misuse is undeniable. Deepfakes, which already generate convincing fake audio and video, could become even more sophisticated and harder to detect with advanced multimodal models, ensuring the responsible development and deployment of these technologies is not just an academic exercise, it's a societal imperative. We must also grapple with the implications for bias. If AI models are trained on biased datasets that reflect societal inequalities, their multimodal perceptions could perpetuate and even amplify those biases, leading to unfair or discriminatory outcomes in areas like hiring, law enforcement, or credit assessment. Transparency in AI decision-making and continuous auditing for bias will be critical. The road ahead requires a collaborative effort from researchers, policymakers, ethicists, and the public to establish guardrails and ensure that these powerful new capabilities are used for the benefit of all humanity. The journey into multimodal AI is not just a technological race. It's a profound ethical and philosophical exploration into the nature of intelligence itself. By proactively addressing these challenges, we can harness the immense potential of multimodal AI to create a future that is not only technologically advanced, but also equitable, secure, and beneficial for everyone. The discussions happening right now in conferences and policy rooms will shape this future, and it's imperative we get it right. So, what do you think about the AI that can now see and hear? Are you excited about the possibilities, or do you have concerns about the ethical implications? I'd love to hear your thoughts in the comments below. If you found this deep dive into multimodal AI fascinating, hit that like button to help us reach more curious minds. And if you want to stay ahead of the curve on all the latest breakthroughs in future tech, make sure to subscribe and ring that notification bell so you don't miss our next video. Your engagement helps us bring you more cutting-edge content.